Continuing on in our structural workflow, after we've solved the model, we next need to make sure we understand how the model works before proceeding with estimation. There are a couple of reasons to do this. One is simply as a test-driven development type of step, which is just to make sure that the model is behaving the way that we would expect it to before we go to the trouble of taking it to the data and estimating its parameters. And then second, it's helpful to understand how the model works so that we can make sure that whatever policy simulations that we have in mind at the very end are going to be feasible and well behaved according to how we've set the model up. We also might want to simply know more about the economic content of the model by making various comparisons. So the main thing that we're going to be doing to learn more about how the model works is to use it to simulate data and then see if that data makes sense based on how we've tinkered with the parameter values. And the way that we can do this is by doing what I would call numerical comparative statics. Comparative statics refers to a purely theoretical model where we would take partial derivatives with respect to certain objects of the model and see what the sign is if we change sum of x without changing anything else in the model. What would that do to y? That's an example of a comparative static. And we can do this numerically once we have our model solved for. So for the example that I've been walking you through with the returns to schooling, we would want to check that if we raised the premium to schooling in the wage equation and didn't change anything else in the model, then that would result in a higher optimal probability of choosing school. We might do the same thing with the parent education coefficient. If we increased its magnitude, then we would expect that to increase the optimal probability of choosing school. Same thing if we increased the taste that the agent has for higher wages. So this would be tinkering with the parameter value for gamma 1. If we have individuals placing more weight on wages, then they should want to go to school to earn the higher wage. And then finally, maybe we play around with the discount factor. If we increase the discount factor, that's effectively increasing the amount of patients that the agent has. That should increase their probability of choosing schooling. We can also walk through this in a numerical example, and I'll pull that up. So one thing that might be helpful is to just come up with parameter values that we think might make sense. We could take them from other papers that have been published that have a similar model that as ours. And we can just generate some simulated data and then see how well that compares with the actual data that we have. So in this example, I'm coming up with different parameters for beta, as well as the standard deviation of epsilon in the wage equation. We've got our experience defined as age minus 18 if they're a high school graduate, age minus 22 if they're a college graduate. And then we just take the values of the rate of college graduation in the data. So whoever's a college graduate in the data, we're going to simulate their wage according to our Mincerian earnings function. And then we're going to compare that with the actual wage that we see in the data. So if we do that comparison, we're going to find that our simulated wages slightly underpredict the wages in the data on average. And we can just kind of use that to tinker around with what parameter values, how could we change the parameter values in such a way that it would make these quantities more in line with each other. Now, obviously, if we're only comparing the average of the log wage, we could always just adjust the constant in the simulated log wage so that it matches on average. But we might also be interested in understanding the spread or other aspects of these distributions. And in the end, we might want to compare correlations between experience and wage or college graduation and wage. And that's getting to our next video, which is talking about how we actually estimate the model. But this process of going through this learning about the model by tinkering with the parameters and seeing how things change, that's a valuable process, in part because it prepares you for estimation, and it also helps you think about how the parameters in the model are identified. So in the next video, we'll talk about how we estimate the model once we've solved it and learned about it, understood how it works. So I'll hope to see you in the next video.